Jai Hind to all. Today, myself Shikha Agarwal is going to give a presentation on a cloud computing in which we are going to discuss about the evolution of cloud computing. I am an assistant professor in IT department of Garg Engineering College. So students, in this lecture, we are going to discuss about a complete evolution, right? So before we talk about the evolution in this presentation, we are going to discuss about the two topics. The first is evolution of cloud. The second, after the evolution of cloud, what is the exact definition? Why it is we are talking about the cloud? So before we start with the term evolution, so we should know what do you mean by the term computing. As per the ACM computing curriculum in 2005, there is one definition comes for the word computing. Generally, when we are talking about the word computing, it means we mean to say any goal-oriented activity required for benefiting from or creating the computers, in which the computing also says, we can say that it is being includes the designing and building of a hardware and software systems for the wide range of a purpose. When I'm using the word purpose, it means there is a connectivity between the network. And why? What is the need of doing that connectivity? Basically, whenever we are having a range of a purpose, it means we can do the structuring, we can do the processing, and we can manage the various kinds of information from the various sources. And simultaneously, we can do the scientific studies of using those computers by making a complete network in which we can make a computer systems in which they can behave very intelligently. And by using that communication, by using all those connections, we can do the communication easily. And once we are doing the communication, we can do a n number of applications by using the computing devices, in which we can do the entertainment, like we can do the media, we can find and gathering the relevant information for a general purpose or for a particular topic also. So when we are talking about the word computing, it is a virtually endless topic because our purpose is never finished. So due to which we can say the possibilities are very vast. Our needs is to be very more, right? So then after that, when we say, if I'm talking about the term computing, in the present situation, in the present year, generally we are talking about the concept of cloud computing. We are talking about the term cloud computing. Before, when we talk about the concept of cloud computing, we should be aware about from where this term comes. Initially also we are talking about the different types of computing, like distributed computing, grid computing, cluster and utility. And after all these types of computing, why we are moving towards a cloud computing? It is being providing the various facilities apart from all these, or either they are merging the various responsibilities from the various types of computing. So this is called the evolution of the cloud computing. First of all, we are going to discuss about a distributed computing. As it is being clear from the word, everything is to be distributed on a separate workstations. So we can say, when I'm talking about the distributed computing, earlier the computing was done on a single processor. Just for example, if I'm talking about the centralized computing, from the given image, you can check when we are having a single mainframe computer, and out of that mainframe computer, everything of incoming and outgoing of the messages or the data is being done with the help of the mainframe computer. Each and every terminal is being connected with the mainframe and they can easily exchange the information. But when I'm talking about the distributed computing, in the case of distributing computing, each and every workstation has its own network, right? Into that case, when we are connecting all these networks or all these network hosts with each other, in which they are having their own memory space, on their own processing speed and so on, then we are talking about the term distributed computing, right? So before that, when I'm talking about a single processor computing, then we can say it is called as a centralized computing, right? Otherwise, we can say when I'm having a distributed the processors or the processing onto the different networks, then we are talking about the distributed computing. When I'm talking about the term distributed computing, basically it is a field of computer science that studies about the distributed system, distributed network, how that particular network is being designed so that we can solve the computational problems, right? When I'm talking about the distributed system, in which we can say there are the several autonomous computation entities in which each of which has its own local memory. So for example, you can see in the previous diagram, suppose if I'm talking about this network host, it's having its own processing area, right? So due to which each and every works as per their own requirements, having their own local memory space. Simultaneously, when I'm talking about the communication between the two entities, they both can connect with each other. They can do the communication with each other by using the concept of message passing, right? Then if I'm talking about the operating systems, as I have already told you that in the case of distributed system, when we are doing solving the computational problems, each and every processor has its own local memory space, right? So when I'm talking about its operating system, the processor communicate with one another through the various communication lines. Just for example, we are using a high speed line or telephone lines, or you can say DSL lines, right? So they are connected with each other through the help of high speed buses or the DSL telephone lines, and they can do the communication with each other. They can exchange the information with one another. When I'm talking about the distributed network, you can see the complete architecture. For example, this is a one host, right, having its own memory space and its own processor speed. Similarly, we are having a three systems in which each is having its own processor and they are connecting with each other. Fine. Then we can say this is called the distributed computing. When I'm talking about the examples of distributed computing, for example, we can say we are using an internet. Each and everyone is using an internet having its own systems, having its own processor speed and so on. ATM machines, intra-networks, and we can talk about the connecting devices in which we are talking about the computing landscapes also. So these all are the examples of distributed system. When I'm talking about the different types of computers in a distributed system, so generally we are talking about the three types of systems or computers in a distributed system. For example, workstations. When I'm using about the workstations, it means the computers used by the end user, like the individual terminal. When I'm talking about that, then you can use the word workstations. Second, we are talking about the server systems. Computers which provide all the resources and the services, then also it is called as the server systems. And the last is we are talking about the PAD. It means personal assistant devices. These all are the devices which is also called as in handheld computers, which is being connected to the system through a wireless link. When I'm talking about its properties of a distributed network, there are a lot of properties which is being beneficial for the concept of distributed computing. So for example, the first common property is fault tolerance. Second, we are talking about that each and every node is having its partial role, right? They can share the resources, they can share the load, they can easily expand the network, and their performance is to be better, efficiently. They can work efficiently. When I'm talking about all these properties of a distributed computing, it gives each and every meaning of that network. Now, if I'm talking about the concept of distributed network, distributed computing, why we require the concept of distributed computing? It provides a lots of characteristics, benefits or properties to the network. That is why we are talking about the concept of distributed computing. The first thing, we are talking about the nature of applications, because each and every individual system has its own processor and its memory space, due to which the fault tolerance is to be easily find out. It will not make any impact onto the complete system. That is why we are talking about the nature of application. Second, if I'm talking about the performance, in the case of performance, we can say it is computationally intensive. When I'm using the word computationally intensive, it means whenever we are giving a task, it could consume a lot of time on computing. जैसे for example, if I give a Monte Carlo simulation tool onto which I need to calculate the value of pi, so it will be a somewhere time consuming. But if I am using the word data intensive, in the case of data intensive, the task that deals with the large amount or large size of files, then it is talking about the distributed network. The best example if I am talking about is Facebook. It generates a lot of data, right? And due to which the data is to be intensive in the case of distributed computing. The next we are talking about its properties, robustness. When I'm talking about the robustness, we can say it works on a SPOF, which stands a single point of failure. Means there is no single point of failure. If a certain node is to be fail, it will not make any impact on the rest of the network. The rest of the nodes can execute the same task without making a difference the failure node. So failure node will not make any impact onto the complete network. When I'm talking about the distributed applications, when I'm using the word distributed applications, there are a lot of applications that consist a set of processes that is being distributed across the complete network of machines, and they all work together and they are being assembled into a common or a single network so that we can solve a common problem from their own sides. In most past, recently we are talking about the concept of client server technologies, but now we are talking about the resource management centralization of the server. Generally, when I'm talking about the distributed network, we are having a peer-to-peer computing also. Peer-to-peer computing says that it represents a movement towards more truly distributed applications. Fine. Now you can see the example when I'm talking about the client invoke individual servers. For example, there is a common server between the network and we are having an n number of clients, right? So it will be processing, or clients means we are talking about the computer systems. They are doing the continuously processing of the system. So whenever the client invoke a call to the server, means request for the some information or data, then simultaneously server will do the processing onto their own system and will generate the result, or you can say it will generate the output. Or we can say when I'm talking about the invoking and result, we can say whatever the request is being in by the client to the server, we will get the output to the in the form of result. When I'm talking about a peer-to-peer processing based on the distributed applications, in the case of peer-to-peer, suppose there are n number of applications on a different peer-to-peer networks work, and they are having an n applications inside a one peer, and simultaneously they are sharing the certain objects. So you can see, suppose we are having a 4 peer networks, and into all these 4 peer networks, they are sharing the n number of resources. These all are the resources which is being shared among the n number of systems. So this is all about the distributed computing. The next we are going to talk about the grid computing. There is a certain disadvantages that of distributed computing is that we are using the distributed networks in which the hardware cost is to be increased. Due to which now we are having a second type of computing that is called as a grid computing. When I'm talking about the grid computing, basically grid computing enables the virtualization of distributed computing and the data resources for such as processing, network bandwidth, or you can say storage capacity, to create a single system image, or like granting the users or applications so that they can access all the IT capabilities into a single unit, right? So just for an internet user's view, unified instance of a content of the web, then the grid user essentially seems to be like a single or a large virtual computers, right? So this is the definition which is being given by the IBM. If I'm talking about the another definitions which was given by the Sun Microsoft, We can say that grid computing is a computing infrastructure that provides a dependable, consistent, pervasive and inexpensive computational capabilities, right? In which we are more dependent upon to the other network. When I'm talking about the grid computing, there is a one more term comes, which is an application you can say, or an example is called as electrical power grid. When I'm talking about the electrical power grid, it means the users are the electrical appliances through which we are getting an access to the electricity through the wall sockets with no care and consideration where how the electricity is being generated and how we are actually using that generation of that electricity. We are simply having a sockets into the walls, and by using those walls sockets we are simply getting or executing our electrical appliances. Just for example, if you are using any electrical appliance at your home place, so you are simply having a switch, and that particular switch is being put it into the socket of the given on the wall side, and similarly we are getting the execution of the electrical power grid. When I'm talking about the power grid, basically it links together the power plants from the different kinds, right? The power plants are of many kinds or from the different ways, and we all are linking together to get the application executed. Then I'm using the word grid. What do you mean by the term grid? Here, suppose we are having in users or you can say client applications, then we can talk about the gaining of access to the computing resources, like you can do the processing, you can do the storage, memory space, data or the applications and so on as needed with the little bit or there is no knowledge about the resources that is being required for that particular technology, or that is hardware, their operating system, their softwares and so on, into which we are simply what we are doing it, we are linking together all the computing resources, and what is that link is being generated in the form of grid or the client applications in the form of PC, workstations, it can be a server, it can be a storage element, it can be wired or it can be in a wireless and so on, and due to which by connecting all those resources we are providing a mechanism that needs to be accessed through them. Then we are talking about the concept of grid. When I'm talking about the grid computing, this is the definition. Now after that we are going to discuss about the various characteristics. There is a lot of characteristics in the case of grid computing also that we can share more than information, because we have created a dynamic environment. We have organized all the systems into a multi-institutional or in a virtual way, due to which we can share more than informations. Second thing, we are having an efficient use of resources at many institutes. When we are talking about solving the problems, we are having a virtual organizations so that we can easily solve the problems of an individual peoples. So people from the many institutions, when they are working onto the common problem, we have to create a virtual organization. So we can easily use the resources. That particular resources is efficiently used by the many institutes. Second is, suppose we are joining the local communities. After that, joining that local communities, you can easily communicate with the people so that whenever the resources are free, you can utilize them. The next is, whatever the interaction with the undernet layers, it should be always remember that these responsibilities or the interaction should be very transparent and seamless to the user. When I'm talking about the concept of grid computing, we should know why we need the grid computing. When we talk about the today's situation, why we need the do the grid computing? Because today's situation, if we see, so everything is to be based on computations. Like if I'm talking about science and research, maths and all, everything is to be based on computations. It means in which we need to have a data, and that particular data is to be analyzed, visualized, and once it is of a similar type as per the requirement of the user, we have to do the collaboration of that data. So due to which the grid computing is required. When we talk about the computer simulations and modelings, somewhere we need to do the experimental methods. So in the case of simulation and modeling, they are more cost effective than experimental methods. When I'm talking about in the scientific and engineering problems, they are becoming more and more complex, and the users are need to be more accurate. They need to get the precise solutions to the particular problems in the shortest given span of time. In spite of getting a long time, they are giving in a shortest time. The next is data visualization is very important in this present situation. So with the help of the grid computing, we can do the data visualization also. And similarly, when I'm talking about the proper utilization of resources, when we are talking about the concept of grid computing, exploiting under the utilizing resources. Now, when I'm talking about the applications of grid computing, there are the various applications where we are using the concept of grid computing. Just for example, crystallography, detection and modeling for the natural disasters, reactor applications, physical applications, and weather forecasting or material characteristics. So these are the various examples or the applications where we are using the grid computing. When I'm talking about the grid computing, there are the 5 types of grids: computational grid, data grid, collaboration grid, network grid, and utility grid. When I'm talking about the grid components, there are the 3 types of components we have. The first is users, groups, and sites. When I'm talking about the users, everything user is being dependent upon the population. Just for example, we are having a large and a dynamic population, first thing. Second thing, we are having a different sites onto which we are having a different accounts, right? The users are having a different accounts on a different sites. If you're working into X organization, you are having a different account. Then if you're moving to the next organization, you are having a different account, and so on. Sometimes the data is to be personal and a confidential also. Second thing is we are talking about a heterogeneous privileges. We are having a different roles and responsibilities. In the case of users also, we are having a desire for a single sign-on problems. When I'm talking about the groups, there are the 3 types of groups: group data, second is accessible patterns, and the third is membership. If you are already the member of that group, you can easily access the data. The third category, we are talking about the sites. Suppose we are having an heterogeneous resources, we have an local policies, certain memberships, or you can say we are talking about the access patterns. Now, after the distributed and the cloud computing, the next type of computing is clustering computing or a cluster computing. When I'm talking about the clusters, it means when we are integrating the single computers and they are interconnected with the collection of computers, then we can say we are talking about the concept of cluster computing. Basically, a cluster means it is a type of a parallel or distributed computer system which consists of a collection of interconnected standalone computers. And when we are talking about the standalone computers, they all are integrated into a single unit and they all are working together so that they can computing the resources easily. When I'm talking about the key components of the clusters, it means we are having a multiple alone computers, like we are having a PCs, we are having a workstations, we are having an SMPs, and so on. After that, we are having a different operating systems. Each and every system is having its own operating system and having an high performance cables to make the interconnections between the systems. We are having a middleware, parallel, or a programming environment through which we can do the different applications. When I'm talking about the clusters are basically deployed so that we can improve the speed and the reliability over a single computer. Right? So if we are doing the clustering of the complete network, due to which it is being very cost efficient, and in comparison to the single system, it is cost effective and of the comparable speed, or in the terms of reliability also. In a typical clusters, we are having a network in which we are having a connection, closer connections of a typical, like if we are within a network, we are talking about the LAN, MAN, and WAN, and depending upon the type of a networks. Then we are having a low latency communication protocols, because everything is to be clustered into a one network in a form of LAN. So there is a latency is being very low. And the systems, they are loosely coupled than SMPs. Then there are the different types of clusters. First is high availability or a failover clusters, in which we are providing the n number of speed to the data, and they are having a failover clusters. The second, we are having a load balancing. It means each and every node in the clusters is having a load balancing method, so that we can easily balance the load onto the complete network. And the third type of a cluster is a distributed or a parallel processing network. When I'm talking about the clusters, there are the three components into the complete clusters, or we can say whenever we are building a block of clusters, they are broken into the three multiple categories. First is cluster nodes, cluster network, and the network characteristics. The first, if I'm talking about the cluster nodes, it means if I'm talking about n number of nodes, they all are being clustered into the one network, right? So this is a cluster network, and in which it is being with the help of switch, the data travels ingoing and outgoing in the outside world, having a cluster components. There are the various key operations for doing the clustering, like system availability, hardware fault tolerance, operating system reliability. There is a high scalability of the system, and if the scalability is high, or it means that you can scale up and scale down the network, then you can give you will get the better performance or the high performance. Now in the last, we are going to talk about the next type of computing, which is called as a utility computing. What do you mean by the term utility? Basically, when I'm talking about the term utility, it is purely a concept which in which the cloud computing practically implements, right? From we can say from here we have started about the concept of cloud computing and so on. Basically, utility computing is a service provisioning model in which the service provider makes computing resources and the infrastructure management available to the customer as they are needed, and they charge them for a specific usage rather than a flat rate. As per their usage, whatever the resources or the infrastructure they are using, they have to pay for it. Particularly, this model has a very good advantage of a low and low or no initial cost is being acquired by the computer resources. Instead of computational resources are essentially rented. When we use the word utility, basically utility is used to make an analogy to all the services, like we are having an electrical power that seeks to be fluctuating the customer's need, charges for the resources based upon their usage rather than the flat charges. And in which way, then you can say this particular approach is called as a pay as per use, or due to which this particular model is also called as a pay you go model. Means whatever the resources you will use, you have to pay for it, in spite of providing the flat charges to the particular services. When I'm using the word utility computing, now let's talk about the definition. It has usually envisioned that there are some forms of virtualization, so that the amount of storage or the computing power available is considerably larger than that what is we are talking about the single time sharing computer. Now you can see the utility. See how much resources is being utilized by the systems. It will provide the function. So say for example, this is a complete IT functions structure, right? Whosoever is required for the resources, they will provide only those resources. Similarly, this is also a node due to which we are providing the services. When I'm talking about the utility computing, it is having a various characteristics. Just I have already told you, this particular is having a first characteristics, pay for use pricing business model. Basically, utility computing is pay for use. How much you will pay, that is the purpose only for the use only. Or you can say jitna aap use karenge, then you can talk about the payment also. The second is we are having in the case of utility, we are also having a data center and virtualization and provisioning method. Whatever the resources is being demanding, everything is to be provisioned to it. Now we are talking about this solving the resource utilization problems. We can easily outsourcing the resources. We are talking about the web service deliveries, and finally we are talking about the automation. Now, if I'm talking about the example of on-demand cyber structure, you can see, suppose there is a one scientist, they wants to do a demand for the web services. Into this case, it will send a request to the for the on-demand request, and finally this request comes to the server or the virtual machine repository. Fine, it will check into the machines, it will check into their virtual clusters, and finally it will provide the services to the network. This is the way how we are getting the services. When I'm talking about the utility solutions, there are the lot of solutions from the different parameters. Just like we are having a service procurement, we are having a pricing, we have an infrastructure, we are having a maintenance, resources, utilization. These all are the common things in which we are talking about the consumers, providers. When I'm talking about the utility computing payment models, there are the various ways to do the payments of the utilities. For example, when I'm talking about the electricity bill, gas bill, telecommunication bill, water bill, or television broadcasting bill, and so on. So there are the various ways how you will do the payment. First of all, we are having a flat rates, right? We are having a tiered rates. We are taking the subscriptions for the particular packages. We are having a meters, and as per your usage, then you have to go for it. Or you are having a pay-you-go model, standing charges, and so on. So customers, depending upon their own various ways, how they will do the payment models for the utility computing. Now, when I'm talking about the lot of benefits in the utility computing, there are the various risks also. First is data backup. Whether there is a backup of the data or not. Data security, partner competency, defining the SLAs, how the SLAs is being defined into the network, getting the value from chargeback. Whatever the charges they have given you, whether you are utilizing those resources or not, right? So these all are the various types of computing in the evolution of cloud computing. After that, we are going to come with the term cloud computing. Basically, if I'm talking about the cloud computing, there are a lot of definitions comes into the market. But according to the US National Institute of Standards and Technology, or you can say NIST, it gives a one definition of cloud computing. That cloud computing is a model for enabling an ubiquitous, convenient and demanding network access to the share of configurable resources. Like you are having an application, services, servers, networks, etc. and so on, with the minimal cost, and the resources is being providing rapidly with the minimal management effort and the service provider interaction. So you can say this is the way how we are having in a complete network, how the network is being designed. We are having a cloud, and onto which we are having a n number of resources is being attached to it, how we can easily access the data. So now in the next lecture, we are going to continue with the next topic, that is a concept about cloud computing. Here I have given a brief introduction and definition about what is a cloud computing. Then in the next lecture, we are going to discuss about what is a cloud computing, what are its characteristics, and so on. Thank you.